next speaker is Tymothy Meyerhoff from Vonage, and he will talk about supporting blue-green deployments and autoscaling in AWS with clustered OpenSIPS.
As Dr. said, I'm Tymothy Meyerhoff. We'll get right into this. So, really what I want to talk about today is supporting blue-green deployments and autoscaling in AWS with OpenSIPS in the context of using a particular OpenSIPS cluster or module to support this. So to get started, our general deployment philosophy for this is treating our automation and infrastructure as code. We build heavily on open source frameworks and tools like Ansible. This is also, we can iterate continuously, implement seamlessly, and do it without hesitation. Constantly pushing out changes to your network obviously raises important concerns about mitigating impact from replacing your infrastructure, deploying code and configuration, and making sure that you're backwards compatible and that when you do fail, you fail quickly and cleanly. We're designed to run in the cloud, distributed across availability zones and regions, leveraging managed services really where we can so we can focus on what's important. And at each step of the way, in this automated process, we want to test, measure, and monitor, make sure everything's going as planned. So kind of really, in order to support a blue-green deployment, bring up this brand new server, it needs all the state from the old one in order to support these flows. So we need to decide how we're going to distribute that state, and really two big options. We have both as the OpenSIPS cluster and different performant databases and distributed cache DB backends. Many of them are available as managed services, but really the great thing is if you're dealing with a use case that's tied to an internal state of OpenSIPS, the cluster fits great. It's high performance, less moving pieces, and it's got tight built-in integration. So changes at the edge of your network are always sensitive. I think we all know that. And heavily automating this process really can take a lot of the strain out of it. Timing is critical. What I found is the more that we shrink the deployment times and times for individual tasks, that just gives us more room to work with, so that if there is something, we can respond to that automatically. And you got to take into account the context of the information that you're replicating. Ensuring, of course, that you're advertising that address that you're moving around, that's floating. And I really encourage anybody, when you're moving a VIP, it's you got to embrace that network disruption, detect the state. Things aren't going to go right. SIP is resilient, so a lot of that resiliency is built right into the protocol. But you can do even more, thanks to the power of OpenSIPS to detect that you failed during a switchover, there's a network disruption, back off, retry, get that eventual consistency. So in the model I'm proposing here, really the clustering is only happening during the blue-green deployment. So I've brought up my new EC2 instance in AWS. I'm now clustering it to share registration on the user log, between the two servers. To show you the switch over here, we're gonna add that new registrar to the cluster DB table, issue a reload, so replication starts up on the servers, and we want to let that soak because in OpenSIPS 2.4 there's a lot of great work to do cluster full sync when this thing comes up. But what we have to do in this case is wait for the registration interval and all that state to go between the servers. Once we're ready, we can do some testing before we actually put customers on it, and then we can go ahead and put that in service, move the floating IP over, update any database, DNS records, and like I mentioned before, we can kind of handle any unusual additional failover states that can help us keep our calls up and calls flowing. So on the next slide, I'm going to show you some performance charts from a little test setup. So to start out here, this was a cluster-enabled switchover with user lock on OpenSIPS 2.2. It's a mix of clients, UDP, TCP, TLS. Some of them in-house clients, some of them, a mix of different phones. This is a registrar that's got users registering directly and through SPCs. It's really a big mix. The largest registration interval on these devices is 10 minutes for the TCP-based clients, but everything else is much lower for UDP, for NAS and whatnot. So we can see here, this is actually the point where we started replication, and then we've actually caught up, both the old and new server, both got user location contacts for everybody at this point. And then actually, as the switchover starts, you see some duplication. We use DNS SRV, and some users move between the registrars. So you get some duplicates, some overlap, but that's great. That means I always know where the person is actually registered. And due to our call flows, it doesn't matter if somebody's got a duplicate registration. This other server is actually out of active service now. And we can kind of see registration rate. This green line and that orange line are kind of backup servers to the ones that are actually being switched over here. This blue to red, and this blue to yellow. So you can kind of see the request rate, under load, how they converge and switch over. Everybody's on active calls, and down calls just keep going. Everybody's active here. So this is another use case for clustering, and using replicated dialogues for context and features. And we can store call and feature context into these replicated dialogues. So that way, I've got all these different soft switches, pre-switch, asterisk, you name it really. And we replicate the state so we can locate calls, determine routing, and mostly provide stickiness for features. I really like to avoid external backend lookups, any kind of database, even CacheDB backends if I can. And a lot of features don't require it thanks to the clusterer. There's always cases where you can't avoid them. It's nearly impossible. But when I can, I do. Show you here some charts from the switchover in this model. This one's a little bit noisier. As we see, I've started clustering, and then after just a couple minutes here, we're pretty much all caught up. So that this new server knows about what soft switches these calls are landing on, if it's a call transfer or call queue or really anything. You can use cookies to kind of keep people on the right servers. And kind of in the context of our next topic, that becomes really important, because what I want to do is use OpenSIPS to enable autoscaling. And OpenSIPS really, it can handle high CPS, high call volumes, and enables that great horizontal scaling that I think we all probably enjoy. So it's a great target for things like AWS autoscaling. It's a managed service. Gives you a pool of compute instances with a managed lifecycle, so you can bring them in and out as your load comes in and out. And I don't know about you guys, but our call volume follows pretty predictable trends during the day. Different lines of business for all different trends, but you can follow that bell curve, so that you can set up scheduled policies to bring instances up, as you need them in advance or in demand to load. Or, one of my personal favorite situations is, say all of a sudden I need to get out of a geographic region. And now I have to either already have all these servers in my other region that's going to support it, or I can scale it up on demand. So I don't have to pay to have all these instances up all the time. It's really helpful. So one of the challenges I ran into really with autoscaling, using both asterisk and free switch, load balancer, dispatcher, lots of options there that all work great. But with RTP proxy, there was a few challenges with the module. Namely, the RTP proxy commands get hashed over those active RTP nodes, and then when you're scaling in, and that hash changes. So imagine I'm mid-offer, I just sent out an invite. The answer's coming back, I scale in, I remove a node, that hash is now inconsistent, and that answer goes to the wrong RTP proxy. So there's really two ways to handle this, that I found at least. One was to use RTP cluster, another great piece of software Maxim's provided that helps you manage RTP proxy nodes. It'll actually manage some of this state for the call, aggregate the sockets, and gives you a little admin interface to do so. But what I actually looked at was going directly to them using the RTP proxy socket database and just making some changes to the module so that I know which RTP proxy I chose. That part's already in there, but then I can say I have the answer comes back. Now I can choose specifically to use that same RTP proxy socket again, and then I can put it into a dialog variable and then even persist it over the call. And then I can make the choice, oh, I'm pulling this RTP proxy out, now I want to go to a new one. So you really have that dynamic way to move calls around in the infrastructure. That's pretty much it.
Do we have questions at this point? Okay.
When you do cutover between, or I guess rather, when you spin up an OpenSIPS instance and add to the cluster, what type of, and I saw it looked like it was like 5 minutes for maybe 30,000-ish registrations. What kind of latency do you see for the cluster to kind of catch up?
So it really depends on the state for user location. It's really your registration interval, right? Because they're only replicating over to the other instance as users come in. And then in OpenSIPS 2.4, they're looking to bring a full cluster sync, so that way you can bring it up, do it quicker.
Okay, so it's dependent upon the actual write of the registration. So if you have like clients that are doing 3,600 seconds, you have a really long spin-up time. Okay.
Yeah, you'd have to like manually propagate them or do something to address that. Yeah.
Maybe blogging is the answer to that one. Is there a way to force user location information to propagate in the cluster? So in the event where, like, if you have very long registration intervals and you want to add a cluster or a proxy to the cluster, can you force replication without having to wait for all the clients to re-register? So the user location propagation happens like immediately.
The only way to do this with the clustering right now, if you force a sync, it's called, or a node. So basically a node you can force to grab from a donor, from another node, all the registration, so basically without waiting for anything to happen from SIP perspective. So you can fetch everything.
So it's possible to do that.
You can trigger that through the management interface.
Okay.
And that's newly available, right, Bogdan, in OpenSIPS 2.4, I think, right?
Yes, exactly. It's in 2.4 available.
Okay.
Any questions for? Okay, that's it. Thank you, Tymothy.